Light is a wave, right? Or is it? All electromagnetic radiation are waves. That's why we have the electromagnetic wave spectrum. But what happens if radiation isn't thought of as being a wave? What changes if we view electromagnetic radiation as particles? We've been told that light is a wave, right? But when you sit down in an A-level class, the teacher may focus on photons of light. What are photons of light? Basically, light particles. Pretty simple. But then your teacher will start explaining why light particles came about. Light was always thought of as a wave, until one day, some random scientist said, hey, let's make light particles, because that would explain what's happening in this random bizarre experiment that we don't know what's going on in. And so light particles were born. These particles, otherwise known as photons, are thought of as being packets of electromagnetic energy. This much makes sense, as we know waves transfer energy from one place to another. This is the part now where things get a little bit more confusing, the part which makes you think that science is just a big joke. Here's an equation for finding the energy of a photon. The one thing that should stand out to you is the lambda symbol. What does this symbol represent? Well, only wavelength. So yeah, that's right, light particles apparently have wavelengths. So to recap quickly, light is a wave and a particle, but when thinking of light as a particle, we also need to consider the particle's wavelength, because why wouldn't light particles have a wavelength? The true explanation of what is happening here is that each wavelength of light will have a photon of specific energy, and this is why lambda appears in the equation. But sometimes you just have to complain about science.